Alright, welcome to our VCarve Pro tutorial video. So in this video, I'm specifically talking about using VCarve Pro to create a circuit board. However, many of the skills and tools that I'm going to teach you in this video can help you when creating whatever design you want in VCarve. So we're going to jump right into here. I'm going to go ahead and open this. Should load up fairly quickly. So when VCarve Pro opens, this is what the window will look like. We want to go over to our startup tasks here and hit create a new file. This opens up a new file for us to work in. And as we can see on the left, the first thing we always do whenever starting a new file is job setup. So we are creating a single-sided job because we're creating a single-sided circuit board. And then we need to input our job size for our material. So all of the blank copper boards in our lab that we use for this are generally 154 by 154 XY, or width and height, millimeters. So down here we can see we can toggle between inches and millimeters. I always set mine to millimeters. And our dimensions are 154 to 154, and our circuit board material is 1.4 millimeters thick. Next we hit material surface for our Z0 position, should be the default. XY datum needs to be our bottom left, again should be just the default, and we can hit OK. So I'll give you a second, make sure our settings look like this, and then hit OK. This will now open up our design page. So on the left we have all these different settings for creating and modeling different designs, but we have already created our design in Fusion. So all we have to do is open up our File Explorer, navigate to where we have our design saved. So for this tutorial, I'm going to be using the 9-volt LED simple circuit. You just have to click and drag it into our page. And here is my circuit. Now, if we zoom out here, we can see that in Fusion, I forgot to delete our border. In VCarve, all we have to do is click and drag and delete this border. I wanted to show you this in case you forget to do this in Fusion. We have to remember not to have our border there. So if you already did that in Fusion, great job. If you forgot, no worries, you just have to delete it here. Now, let's get back to this. Our circuit board, whatever it looks like, whether you're in grade 9, 10, 11, 12, whatever your circuit board looks like, you should have our copper paths and terminals without any lines separating the terminals, or the copper pad here, from the path. And we should have our border. So whenever designing, it's always a good habit to drag this design into the bottom left corner, because this is where our 0 is. I'm going to click and drag to select everything. We're going to go over to our Edit Objects tools, and we are going to go to this third selection mouse, the Transform Mode selection. This then allows us to grab and drag this right into the bottom of our page. If we zoom in, I'm going to align this so it's right in the bottom corner. Alright, now that our circuit board is in the bottom left of our page, there's one thing we have to do before creating toolpaths. Now, let me show you what happens when I click on one of our copper profile paths. We can see it just selected this one section of the line. And that is because when we imported our file, it created or recognized these lines as a whole bunch of individual little lines. Now, what we want this to recognize it as our full complete paths. So the way we fix this is we click and drag to highlight all of the lines, so we want to do this for our whole circuit board, we're going to go over to our Join Open Vectors tool. As a shortcut, you can hit J, and it'll open up our Join Vectors option. So whatever this default is, I believe it's supposed to be 0.001, we can hit Join, and it will join all of these. So now when I click on this, or this, it selects that whole path. We hit Close, and now we're ready to start creating our toolpaths. Now by toolpath, I'm talking about the literal path that our CNC tool is going to make when cutting our circuit board. So we're going to go up here and open up our toolpath window. We're going to hit this little auto hide pin button to lock our window on our screen. The first path that we are going to make is the profile of our copper paths here. So to create a toolpath, we go over to Toolpath Operations, and we pick one of our toolpaths. For our profile, we want to find the Profile toolpath, which is the top left one, and it opens up a 2D Profile toolpath window. The first thing we want to do when we're creating a 2D Profile toolpath is select all of the objects that we want to cut. Now, because this is cutting out all of the copper that we want to leave behind, we are going to cut out or select all of these lines which outline the copper that we want to leave behind. You can basically think of this as anything inside this shape is going to be copper that is left behind, anything outside is going to be copper that is cut. Once you have our vectors selected, we can go over to our cutting depth and start filling in our settings here. So for copper, we want our cutting depth to be 0.3 millimeters deep. And our start depth should stay at 0, so cut depth is 0.3 millimeters, and then we move on. Okay, the next step here is to select our tool. So this is the cutting tool that the CNC is going to use for this path. So I'm going to go in and hit select. And we need to find our ball nose 1/32. Now, there's a lot of settings here that are all done for us. But there's one setting we have to pay attention to, and that is our tool number. Our tool number indicates which position in our CNC's auto tool changing cradle this tool, our ball nose 1/32, is sitting in. So our MDX50s have 6 cradles that our tool could be resting in. When creating this, you have to go over to the machine and confirm that in tool number 4 we have a ball nose 1/32, and you have to do this for every single tool you select. Once I've confirmed that, I'm going to hit select, and I'm going to move on. For our machine vectors option, we want to make sure that our tool bit, our tool cutting bit, is cutting on the outside of this line. Otherwise, it's going to take away from the amount of copper on our path. So we're going to hit outside/right and keep scrolling down. For this first copper profile path, we want to name it our name and copper. This tells us what this toolpath is actually doing. We hit calculate, and there it goes. So every time we calculate a new toolpath, it creates this window here, this preview toolpaths window. We can hit preview all toolpaths, and it'll show us what the machine is going to do. We can hit reset and close it, and we are going to move on to the next toolpath we're going to create. The next one we want to make is our drilling toolpath. So I'm going to pick drilling toolpath, and again, we have to pick every single option that we're drilling. So no matter what circuit board you're making, whether it's grade 9, grade 10, grade 11, grade 12, it's all going to be the same ideas. The first profile toolpath, you're picking all the copper paths that you want left behind. Our drilling toolpath, we're picking all of these holes that we want to drill. And just because I didn't mention it before, you want to click one and hold shift while you're clicking on every hole or every object. And this way you will select multiple objects at the same time. Okay, drilling toolpath is super easy. You select your vectors, so all of these holes. You set your cut depth to 1.8. We're going to try 1.8. So this is going to cut through our copper, through our circuit board material, enough that it's going to make a nice sized hole to fit our components through. And our tool should already be set to 1/32. If not, you already know how to do this. Make sure ball nose 1/32. It's good that I clicked in here because we see our tool number is changed now. Make sure whatever tool number you have for your ball nose 1/32 is set correctly. This is the importance of checking every single time. We're gonna hit select, and now we've selected our tool. Once you've input your cutting depth and your tool, we hit title it Mr. D drill, and we calculate. It's going to give us a warning that this is going to cut through our material. We want to drill through our material, so this is good. We hit OK. Now we see we've got two tool paths. So if we preview, it's going to show us what it's going to look like. That looks good. Now carry on. You don't have to preview your toolpaths every time. I generally just like to because it's quick and it lets me know that I haven't done anything wrong. Or if I have done something wrong, it illustrates that and I can go back and fix it. Alright, the next toolpath that we're going to create is a pocket toolpath. Now if you're in grade 9, you can skip this step. I do this step for you in grade 9. However, for everyone else, we are going to go up here and find Pocket Toolpath and hit click. Okay. Once again, the first thing we have to do is select the vectors that we want to cut. However, unlike drilling and profile, a pocket is actually going to cut everything in between the vectors that I pick. So as an example, if I were to click these two vectors, it is going to clear away everything inside of these vectors. So it cut everything inside of here. Now, for our circuit board, we want to create a pocket between our border and our copper profiles. So I'm going to pick our copper profiles and my border. I'm going to go over here and pick 0.3 millimeters. Then, once again, we want that ball nose 1/32. Make sure it's on the right tool number. We're going to scroll down, title this Mr. D clear, because I'm clearing out the path, and hit calculate. Okay. And we can see it added all these extra lines, and it actually created 4 different tool paths. So we're going to preview this, see what it looks like. There we see it's cleared all of that copper away. I'm going to reset this and close it and explain what these 4 tool paths are. If I hover my mouse over top of it, we can see a whole bunch of information about that toolpath, including, if we look at the second line of text, the tool bit being used. So for this one, it is a 1/32. If I turn this on, it's going to show me everything that 1/32 tool bit is doing. So we can see it's actually not doing a whole lot. But if we hover over this next one, let me turn that on. You can see it's starting to do a bit more. Okay. The reason this has created a whole bunch of toolpaths is because, let's hover over clear number 2. Right there, you can see our end mill is now a 1/8 end mill. So this program, what it's doing is recognizing that it would take forever to clear this path out with a 1/32 tool bit. So it's automatically selecting a 1/8 tool bit and even a 1/4 inch end mill to clear out these bigger areas to speed up our job. So our program is making it nice and easy for us to have a quick job. So all together, we can hit preview. When you put those all together, it clears out the space in between our profiles. So this is doing a lot of work for us. It's a great program. Let's get into our final toolpath. So at this point, we've cut out our profiles, we've drilled our holes, and we've cleared everything in between. The only thing left is to cut out our board. So to do that, we are going to do another profile toolpath. Only this time we want to cut right through our board. So I'm going to hit 1.5. We put in 1.5 because we want to cut a little bit past the depth of our circuit board. However, we don't have to worry about making a nice sized hole to fit our terminals from our components through. We only have to worry about cutting through our board. If you want me to explain that further, you can ask me in person. But for our profile of our board, we're going to hit cut depth 1.5. Once again, we're using our ball nose 1/32 tool bit, and we're going to hit, doesn't really matter, but I'm going to hit 1 here, or on here. Now, there is one other setting that we have to make sure is turned on when cutting out our board, and that is this add toolpaths or add tabs to toolpath option. What toolpath tabs are essentially small little pieces of material that are going to be left behind to keep that piece attached to the stock material, the material we're cutting out of. Because if I were to just cut this out and it was just sitting there loose, it might catch on my tool bit and go flying, hurting itself, our piece, or the machine, or damage something. So we want to add these little tabs on, which we can easily snap off when we go to take it off. But we'll keep our material secured. So I went to hit edit tabs, and it reminded me that I have to select the vector that I want to cut. So once that's selected, I hit edit tabs. We can just go over here, hover over the line, and add a couple tabs. Now this is a very small circuit board, 1 inch by 1 inch. You're going to want to add 1 to 2 tabs per side depending on the size of your circuit board. So for this one that's really small, I'm only going to do a couple because it's not going to take much to hold this one down. But as you get bigger, you're going to want to add more. So grade 9s, this is your circuit, add 1 to each side. Grade 10s, who are doing the 2x2 circuit, probably add 1 to 2 per side. So add 1 on all the sides and hit close. After that, we can scroll down, title it your name and board, and hit calculate. Once again, it's going to say you're going to cut through this, that's okay. Alright, and with that, we have all our toolpaths selected or created. So if we preview all our toolpaths, we can see here our tabs have been created. It's going to cut everything out and then cut our board out and then add the tab, or also leaving behind the tabs. leaving us with a fully finished circuit board. And then we are going to check our summary of all toolpaths. This is going to say our total machining time is 11 minutes, which is great. And then we're going to hit Save Toolpath. So in this setting, we're going to have to set our machine. So if we're cutting circuit boards, we are cutting our MDX50 machine, and we want this set to the MDX50 ATC. We need to make sure that we have the ATC option selected, because this is going to have our machine change its own tool in between every toolpath. The alternative is we would have to go and run every single toolpath separately. There's a lot more work for us. So just click ATC, and then you're going to take your computer and plug it in to our CNC. At this point, you should come and get my help. Unless we've already went through this together, you should come and get my help. I'll monitor you plugging in, setting up the CNC. But at this point, you are all done in VCarve, and you can go and move to the CNC itself. Once your CNC is set up and you're plugged in and everything, you're going to hit Save Toolpath, and once you click this button, it's going to automatically print to the CNC. So don't press this button until you've checked with me and we have the machine all set up. At this point, we're done in VCarve, so I'm going to stop the video here. So you can just get to work. So thanks for watching, and good luck with your project.